Okay, class, we're back again. We're working with more exponents, and now we've got some basic exponents that we should be able to do without a calculator. Notice, do not use a calculator. I can't really tell if you were or not, but I'll show you how we solve them without a calculator. First thing is, in order to do this without a calculator, it has to be easy math. Can't do it without a calculator. So what we got to do here is we have to identify what base these two sides of the equation have in common, and hopefully you see that it's base 5. So I have 5 raised to the x plus 1, and that's equal to 5 squared. So once you see you have the same base, you can then set the powers equal. So this one was equal to 1. And on the next one, hopefully you see that 1/3 is 3 to the negative first. And here we have 2x plus 2 as our other side's exponent. And now since the bases are the same, we do the same thing we did before, set the powers equal. And we have 2x is equal to -3, and x will equal -3 halves. So I hope you found that helpful. Now we have the other type of logarithmic equation we want to solve. This is where you have a logarithm and you're supposed to solve it with that calculator. Now it's very important. Anyone coming into calculus, whether you're from regular pre-calc or honors pre-calc, we'd like you to be able to convert a logarithm to its exponential form. So in this case, we will say 2 raised to the third power equals x. So 2 raised to the third power is equal to x. So for this, x has got to equal 8. So in other words, when you're looking at a logarithm, you say you have the base 2 logarithm of 8, that should equal 3. So we'll just check it. 2 raised to the third power gives you 8. Moving right along. I'm hoping that this one works out. I'm identifying that I have all base 3 logarithms. And from last year, one of the things that we first did in regular pre-calc was we first made sure that coefficients were put in the power position. So I'll just rewrite this. Log base 3 x squared equals log base 3 of 4 squared minus log base 3 of 5 to the 4th. Now I'm going to compress these logarithms on this side. So I'm going to have log base 3 of 16, that's what 4 squared is, divided by 5 to the 4th, which is 625. So what I basically did 2 steps in one, where 5 to the 4th is equal to 625, and 4 squared is equal to 16. And because of the subtraction here, that makes when you compress the logarithms, it becomes a 1 logarithm of division. And on this side, I have log base 3 of x squared. So now that you have a log base 3 of x squared is equal to a log base 3 of 16 over 625, you could just set the internal part of the logarithm equal to the other internal part. And now your answer is x will equal 4 over 25, plus or minus. Now, let me pause and I'll be right back. Okay, I'm back. I was just checking the answers to make sure that we were still on track here, and we're doing pretty good. So on number 6, just some simple properties of logarithms. Remember our basic property, log base b of b to the x results in just being x. Or you could say b raised to the log base b of x. They undo each other and you get x, because the logarithm base b and the exponential function b to the x are inverses of each other. We talked about that last year in pre-calc. Yeah, that seems like a million years ago. But that's a property that I'm going to use to work on these next few problems. So I'm going to, as you can see here, this is base 10 logarithm of 10 to the 1/2 power. So what happens is the base 10 logarithm wipes out the base 10 exponential, so the answer to this should be just 1/2. On the next one, this is a base 10 logarithm, so I'd really like to change this to base 10 exponential, which I can do. Log base 10 of 10 to the negative x. And that would become, the answer would be negative x. And on the next one, I notice is base 10 and base 10. So I'm going to change this logarithm, log base 10 of the square root of x, but that too becomes a power over here. It comes up to the power position, and this 3 goes up to the power position here. So plus log base 10 of x to the 1/3, but when I cube it, you guys know what happens when you cube a cube root. They undo each other just like squaring a square root. So right here I have log base 10 of x plus log base 10 of x. So now I can put these together. When you add two logarithms, I have log base 10 of x squared. Or some other people might say, hey, McAllen, why don't you just add them together and you get 2 log base 10 of x, which would also be log base 10 of x squared. So that is it with the logarithms. Now we have a new type of problem to work on. Solve for the indicated variable. Solve for a in this case. So this one, we don't care about. This is basically like a volume equation, and we want to just solve for a. So we've got to basically distribute the two. Now the terms with a in it are free to be moved around the equation, so I can just leave them on the right side. And it may help you as you look at these videos to kind of like pause the video and see if you can get to the next step without my help, and then see if you guessed right. That would probably be helpful. So now we move the BC term over to the other side, and we need to solve for a. So I'm going to try to separate a from these two terms, and I'm going to factor out the a. Oops, I didn't do that there, so let me just write 2b, 2c, and I have volume minus 2bc. So now the final step will be just solving for a. So this is multiplication here, that times that. So what I'm going to do is divide out that term, and I'm going to have the volume minus 2bc over 2b minus 2c. And that would be my final equation solving for a. We're done with page 3, so I'm going to stop the video here and post this page and move on to the next problem for the next video, or the next page.